Welcome back to another episode of World War II Jeep and Rifle. Today I'm going to do something a little bit different and kind of do a lesson on some troubleshooting of my PE-237 power unit. It's a vibrator power unit from World War II used to power the BC-1306 and also could power the later Angry 9 or the ANGRC 9 radios from the 50s and 60s. These were AM radios that transmitted between 2 and 8 megahertz, or in the Angry 9 case, I think it's between 2 and 12 megahertz. But the power supply is what was giving me trouble. The PE-237, hard to find, vibrator power supply has a low side for receiver only and a high power side for sending and receiving. And it was working fine, and then all of a sudden I was transmitting, and the power supply just cut out. It tripped a breaker, in fact. So anyways, I want to point out a couple things. One, you got to get the manuals. Even if your PE-237 is hooked up to a BC-1306, I suggest you get the TM 11-263 technical manual for the Angry 9, because it's got a pretty decent section in it on the PE-237. Just a couple things about the PE-237. If you're not into electronics or familiar with electronics or just haven't dug into the PE-237, here's a description. The power supply hooks up to the vehicle battery. The battery power goes through a circuit breaker, in which case mine is tripping now. Every time I put the radio into transmit and receive or send mode, it trips the circuit breaker. On a working unit, the power from the circuit breaker activates a vibrator. This is direct current, DC, either 612 or 24 volts from your vehicle. Goes through a vibrator. The vibrator creates an alternating wave source that goes through a transformer to step up the voltage from the alternating current created by the vibrator, and then it is rectified so that you get a DC output of a higher voltage than the input. That rectified signal goes through a filter to take out try to flatten the waveform and to suppress any RF from getting into your radio from the power supply. The standby side, which is for receiver only, goes through one vibrator and a different set of rectifier and filtering elements. And the heavy duty section is similar block diagram: a big vibrator, a big power transformer to step it up, a bigger rectifier that glows purple, vacuum tubes, really cool, and its own filter elements. So some things that I'm going to tell you about the high power side. This is the after the vibrator. Here's the big transformer to step up the voltages. Goes through this rectifier. And then it goes to the socket for connection to the radio. I was able to troubleshoot a few things. Remember, my circuit breaker was tripping, so I would reset the circuit breaker and try a few things. One thing I tried was pulling the vibrator out, and it didn't trip the circuit breaker, but it certainly didn't vibrate and nothing worked. So I put the big square vibrator back in and pulled the rectifier out. When I pulled the rectifier out, the vibrator vibrates, the circuit breaker doesn't trip, but of course I'm getting no output, because this is a critical path for connecting the stepped up voltage to the output. So no output, but I wasn't tripping the breaker. So when I put the rectifier tube back in, as soon as I flipped the switch to turn on the power, the radio connecting up the high voltage side, I noticed that this rectifier instantaneously glowed its filaments very bright, and then the circuit breaker tripped. So I knew that there was high power coming through the filament side, which is where the glowing comes from. High power coming through there without the rectifier in place. No circuit breaker was tripping. Vibrator was working fine. So I could eliminate, the front side of this whole circuit, which is not drawn. I then tried a different rectifier tube, just in case. Same exact thing. It instantaneously glowed bright and then tripped the breaker. So I felt like with identical symptoms in two different tubes that it wasn't the tube, and that there was current draw somewhere else in this path. So you get 500 volts right here. See that? 500 volts. My theory was that I had a short, and I had to isolate where that short could be. So I picked 3 components to try. I picked, just looking at the different capacitors, I felt like it was probably a shorted capacitor. I picked capacitor 715. That's the biggest capacitor in the output path. If it's shorted to ground, then I could be drawing a lot of current. 4 microfarads, biggest capacitor. The second capacitor is sort of it's a single component with 2 capacitors built into it, 714. A 0.5 microfarad capacitor and a 3.5 microfarad capacitor. So I thought, that was my second guess. My third guess was this little guy, 0.04 microfarads between the 500 volt side and ground. And if none of that worked, I was going to go to capacitor number 739, a 0.02 microfarad capacitor, 2-sided. So that was my intention. 1, 2, 3, 4, to one at a time disconnect these capacitors from the circuit and see if I could eliminate the tripping of the breaker. I felt like with these out of the circuit that it would probably still work. It just might be noisier because these are really part of filtering. So that's my approach, and I'll show you some more in a second. So the next thing I don't have in the video, but it's disassembling the PE-237. Disassembling the PE-237, my best suggestion is it was hell. And you gotta get the manual, get the technical manual, and go through each of the steps. Follow the steps. They're written down. They didn't write down that you have to use a rubber mallet. And that you're going to maybe break your back doing it, because this is a big, heavy thing, and there's a lot of tar and antifungal crap in there that kind of makes things stick. So, a couple things to note. You basically disconnect the big battery cables and the cable connector for connecting to your radio. You take off the terminal board, you unscrew the wires for the cable, the female output receptacle, and you pull the receptacle out, you pull the cables out, and then you pull these bushings out. You have to do that to make clearance to turn the PE-237 upside down, remove 6 nuts, and then pull the chassis, the cover, the bottom cover away from the chassis. All that is easy to say, but man, backbreaking to do. The hardest part for me was when I pulled the nuts off of these 6 posts as it's upside down, the cover just would not lift off of the radio chassis. I had to prop the cover on 2x4s so that there was a little bit of an air gap between the radio components on the chassis and the cover. And then I beat down with a rubber mallet on the top of these naked bolts until it freed all the glue and adhesives and crap that was holding this. In addition to the nut that was screwed onto the bolt from the outside, there was other stuff that was creating mechanical resistance. Anyway, what a bummer. All right, so I'm gonna take you to the ugly guts of the inside of this thing and show you what I found. Okay, so here's my test radio. It's an Angry 9, and here's the PE-237 on its side and removed from the cover. So if I kind of turn the camera like this, you may recognize the top. And because that's what you can see with the cover off of the top cover off the PE-237. Like I showed you in the diagrams, you have to pull the power cables out. I've had to put them back on so that I could do my testing. And you pull this receptacle out of the bottom cover, and then you pull it with its wires. Okay, its wires are connected to this terminal block. So I pulled it, removed the chassis from the covers, and then put it back in just for testing. So piece by piece, like I said, I had to eliminate capacitors. The first capacitor was this one. This was the 4 microfarad capacitor number 715. I pulled it out of the circuit, and it still tripped the breaker. I tested this capacitor, and it's got 0 microfarads. It's not shorted, but it's also not functioning. So I'm gonna have to replace this with a modern capacitor. I'm not going to try to rebuild this oil-filled capacitor or buy one. They're like 150 bucks. So attempt number 1, that was not the problem. Still tripping the breaker. All right, then I went to number 2. Number 2 from the top is this capacitor, and from the bottom, I'm not sure you can see it. It's really hard to get at. Let me try tilting this radio just a little bit more. Okay. So for orientation, the front of the PE-237 is over here. The vibrator and the big vacuum tube rectifier are on top of this thing on the other side. That big oil-filled capacitor, number 714, which is a dual capacitor with a 0.5 microfarad and a 3.5 microfarad, you get to it way in here. And I don't know if I can get these cables out of the way. I don't want to do too much, but there are some, yeah, you can see some bolts down in there. The wires are bolted on, fastened on through those bolts. And I removed the nuts and disconnected the wires one at a time, trying to isolate, and eventually, was able to get a non-functioning radio. But I determined through measurements that the capacitors were fine. So that capacitor is also fine. Not the other big oil-filled capacitor. So that's not it. Then I went to the third capacitor. This is the little guy, 0.04, capacitor number 736. Again, going through that technical manual, that's the key to finding which component is which. But this is number 736 right here. It's usually held in place in this little sleeve. I had to clip its lead and to disconnect it. I clipped the lead to disconnect it and tested it, and it worked. The power supply worked. That was the failing component. I've measured it. No, it does not have, it's not measuring capacitance. It's shorted. And so I found a similar capacitor, 0.04 microfarads. It has to withstand a lot of voltage because it's in a 500 volt path. So this one is temporary until I get a appropriately sized capacitor. And that ended up being the problem. So this little guy was shorted, killed my power supply. And as I disconnected it and replaced it in the circuit, it now, the PE-237 now works. All right, so I'm going to do a live test now and show you this vibrator running kind of out in the open like this. I've got a 6-volt battery connected up to it. I've got the faulty component disconnected, a replacement component in its place. And first of all, I'll show you the standby side or receiver only side and the small vibrator circuit running. So you can hear the little vibrator running. That is back here. That's VB1, and it's running through a small rectifier down in here. Okay, and that's providing filament voltage for the receiver and plate voltage at about 100 volts. You can hear it through my loudspeaker in the receiver. Just a gentle little hum. Now I'm going to switch it over to the SIN side or the high power side of the power supply. This big vibrator, VB16, is going to buzz very loudly, and this large rectifier tube is going to glow and rectify, providing 500 volt output to the transmitter. So here we go. There you go. You can see the filaments flowing in the rectifier tube. Got sort of a plasma. Really cool looking. That's probably the coolest vacuum tube there is. And Kilo Golf 5 Yankee X-Ray Papa CQ. So transmitter, receiver, everything's working. Just had to put a little elbow grease into it. So I can't tell you how happy I am I got this thing working. It was not easy. Mostly it was a physical effort. You know, based on the schematic, I had some pretty likely candidates. I had a systematic approach, but getting to each piece was killer. So anyway, that was kind of an advanced video. I bet you there's about 6 people out there who will ever watch this and actually need to use the information. But I wished that I had been able to find a video of somebody really working on a PE-237 while I was going through this. So maybe this will help you guys. And if you like the video, please subscribe to the channel. We'll keep showing you more. Have fun. See you later.